Hey everyone, my name is Rajiv. Welcome back to my channel. In this video, we'll be learning about one of the most important CPU scheduling algorithms in operating systems, the shortest job first or SJF scheduling algorithm. We'll understand what it does, how it works step by step, and we'll also run this Python program to see its output clearly. So first, what is shortest job first algorithm? The shortest job first algorithm is a CPU scheduling technique that selects the process with the smallest burst time. In other words, the job that takes the least CPU time and executes it first. It helps minimize average waiting time and average turnaround time, making CPU usage more efficient. And since this version is non-primitive, once a process starts, it will continue until it finishes without being interrupted. Let's understand this with an example. Imagine we have four processes P1, P2, P3, P4 with burst times like 6, 8, 7, 3 milliseconds respectively. Here the process with the burst time 3, that's P4, will execute first, then P1, then P3, and then P2. That's how SJF decides the order. The shortest job first. Now let's dive into the Python program you can see on the screen. The title says non-primitive shortest job first schedule. First, the code takes input from the user. N is equals to int input enter number of processes. This line asks how many processes we have. For example, let's say 4. Then we create any empty list called processes. Next, using a for loop. For I in range of n, we ask the user to enter the burst time for each process. Each process is stored as a list with two values, its ID number and burst time. So if the user enters 6, 8, 7, and 3 as burst times, the process list will look like 1, 6, 2, 8, 3, 7, 4, 3 in a square bracket style. Now the code sorts the processes according to the burst times using this line. Processes.sort key is equals to lambda x is to x of 1. Here x of 1 refers to the burst time in each sublist. After sorting, the processes list becomes 4, 3, 1, 6, 3, 7, 2, 8. So process 4 will be executed first because its burst time is the smallest. Next, two lists are created to store waiting times and turnaround times. Waiting time is equals to 0 into n and turnaround time is equals to 0 into n. The waiting time for the first process is always 0 since it runs first. Then for each process starting from the second one, we calculate waiting time is equals to waiting time I minus 1 plus process of I minus 1 and 1. Let's calculate manually. For example, P4 waiting time is 0 and P1 is 0 plus 3 is equals to 3. P3 3 plus 6 9 and P2 9 plus 7 16. So the waiting times are 0, 3, 9, 16. Now we calculate turnaround time using this formula. Turnaround time is equals to waiting time plus process of I. Here turnaround time means the total time taken from the start of the process until it completes. For example, P4 is equals to 0 plus 3, 3. P1 is equals to 3 plus 6, 9. And P3 is equals to 9 plus 7, 16. And P2 is equals to 16 plus 8, 24. So the turnaround times are 3, 9, 16, 24. Now comes the output part. The program prints the results in a tabular format using the line print slash n process slash t burst time slash t waiting time slash t turnaround time. Then a loop runs to print all the values neatly. Okay. So now let's run this code. So now let's enter the processes P1, P2, P3. So average time, turnaround time, and the users. These all are given neatly. At the end, we calculate and display average waiting time and average turnaround time using. These values show how efficiently SJF minimizes the waiting time by always executing the shortest job first. To summarize this, shortest job first is an efficient CPU scheduling algorithm. It reduces average waiting and turnaround time. But one drawback is starvation. If shortest process keeps coming, long processes may never get CPU. Now let's talk about the preemptive schedule. Primitive shortest job first. Okay. So this is the code for this. And then now let's discuss about this. This code implements the primitive shortest job first scheduling algorithm, also known as the shortest remaining time first, SRTF. Let's go through it step by step. First, the program takes the number of processes as same as the non-primitive. N is equals to int input enter number of processes. Then it creates an empty list called processes to store each process's details. Inside the loop, for every process, the user enters arrival time, burst time. Each process is stored in the form of process ID, arrival time, burst time. For example, if you have three processes and enter, P1 arrival time is 0 and burst time is 5, and P2 arrival time is 1 and burst time is 3, P3 arrival time is 2 and burst time is 1, then the list will look like 1, 0, 5, 2, 1, 3, and 3, 2, 1. Now, next remaining given as remaining time is equals to P of 2 for P in processes. This creates a list of the remaining burst times for each process initially equal to the burst times. The other variables are complete is equals to 0 to count how many processes have finished execution, and T is equals to 0, the current time, and minimum bit is equals to 9999 used to find the process with the shortest remaining time. This is used for the finding the shortest remaining time. And short is equals to 0, index of the currently running processes. Check is equals to false, flag to check if a process is available to run. Then we initialize wait is equals to 0 into n for waiting times, T8 turnaround time is equals to 0 into n for turnaround times, finish time is equals to 0. The main logic of the algorithm runs inside a while loop. While complete not equals to is equals to n. This means the loop continues until all processes are finished. Inside this loop, we check every process one by one to find the processes with the smallest remaining burst time. Among those who already arrived, we can check this. In this for loop, for j in range of n, we check three conditions for each process. Its arrival time is less than or equal to the current time t. Its remaining time is less than the current minimum burst time. Its remaining time is greater than 0, not yet completed. If these are true, we select that processes are the current shortest one, storing its index in short and marking check is equals to true. If no process has arrived yet, check remains false. It means the CPU is idle at the moment. So we simply increase the time t by 1 and continue the loop. Okay. And when a process is selected, we decrease its remaining time by 1. Remaining time short is equals to 1. Then we update minimum bit with the new remaining time. If the remaining time becomes 0, we reset minimum bit to a large value 9999 so that the next shortest process can be picked. When a process finishes, remaining time short is equals to 0. We increase complete by 1. Mark check is equals to false and calculate its waiting time. Finish time is equals to t plus 1 because the process just finished at the time t. Waiting time is calculated as WT of short is equals to finish time minus burst time minus arrival time. So waiting time can be calculated by minusing the finish time minus burst time minus arrival time. If this waiting time becomes negative, we make it 0. This ensures no invalid waiting times appear. After every time unit t is incremented by 1 to move the simulation forward. Once all processes are completed, we calculate the turnaround time. Using this formula, turnaround time of I is equals to processes of I, bracket 2 plus waiting time of I. Turnaround time is equals to burst time plus waiting time. We can also use this formula. Finally, the program prints a clean table using print /n process /t arrival /t burst /t waiting /t turnaround and displays each process arrival time, burst time, waiting time, and turnaround time. For example, now let's run the program. We give the processes. 234. So the processes are given average waiting time and average turnaround time. So this is about shortest job first. Thank you, everyone. Thank you.